Aircraft carrier development started as soon as the Wright brothers took to the air. However, it wasn't until World War II that the practice of using planes off floating platforms was tested in combat conditions. The ships went through an evolution process, but it was the aircraft that underwent major refinement to be useful at sea. This week, we explore the early development of the carrier and the Grumman Hellcat. This is a Grumman F-14A Tomcat. It's amongst today's ultimate weapons. It was conceived in the late 1960s to replace the F-4 Phantom. To take off, the plane is catapulted 200 feet. Within this distance, the plane will have accelerated to 170 miles per hour in 2.5 seconds. A very large fighter, the Tomcat is considered an icon by many aviators, but this is not Grumman's firstborn carrier-based legend. During World War II, aircraft development and improvement accelerated, and many great planes were the result. However, the Grumman Hellcat's military record stands alone. This plane was a total package. It had speed and maneuverability, and it was extremely sturdy. Ironically, one of the best fighters in history was basically an afterthought. The F-6F Hellcat was rushed into production and first entered combat on August the 31st, 1943. Today, after much trial and error, we're able to very successfully operate planes from aircraft carriers. The Harrier jump jet is one example of a modern naval fighter. Although it wasn't designed just for aircraft carrier use, the Harrier is very much at home on the sea. With its vertical takeoff and landing capability, the jump jet requires only a small carrier. For a smaller naval operation, the plane can even be flown from or landed on a ship's helipad. In 1909, we were barely able to claim mastery of building petrol-driven four-wheel vehicles, or cars as they became known. Yet some forward thinkers were already adapting the internal combustion engine to powering aircraft. In Virginia, during one of the Wright brothers' subsequent flights of their Kitty Hawk, a naval observer, Lieutenant George Sweet, reported back that the Navy must have that. It will be most important to us. With these words, Sweet basically instigated the joining of air power and naval power. The Navy's first attempts at air power concentrated on taking off and landing on water. In 1910, and again in Virginia, a civilian pilot named Eugene Healy tested the idea of taking off from a ship and landing on terra firma. He uses a wooden ramp built over the bow of a cruiser as a runway for a 50-horse-powered Curtiss. He's successful, and 2 months later he attempts the reverse, taking off on land and touching down on a ship. Again, he's successful. The next achievement towards aircraft and their use at sea occurred in 1921, when the US Navy ran bombing tests on captured ships. Brigadier General Billy Mitchell oversaw the operation. The newspapers were quick to announce that with such a devastating weapon as the plane, the day of the battleship was over. The Navy was quick to remind the media and people that the battleship used in the test was a sitting duck. It didn't return fire or in any way take defensive action. During 1922, the battleship Jupiter was transformed into the USA's first aircraft carrier. It was renamed USS Langley. Arresting wires were strung across the deck of the runway, and planes were fitted with hooks, which would snare the wires and bring the plane to a halt. Braking systems for planes had not been designed, and the pilots flew without the use of safety harnesses. The first of many problems became apparent. The undercarriages were simply not strong enough to cope with the rough landings. The pilots, not wishing to miss the wires and end up in the sea, slammed the planes down very roughly. The Hawk Company, which built most of the first planes, knew about the problems they would face in constructing a plane that would stand up to the rigors of carrier landings. Even though the planes of the day flew quite slowly and could glide down well, they were lightly constructed, and now the designers were faced with strengthening the plane and adding weight. Strong and lightweight metals such as titanium or materials such as carbon fibre were not yet available, so strengthening came at a cost, and the cost was weight. However, some remedies were simple enough and made enough difference to prove that using planes from the Langley was feasible. These included designing planes that gave pilots better visibility over the nose of the plane to give them better judgment while landing, widening the track of the undercarriage to increase stability, and better training procedures. The British were also developing sea takeoffs, and this was one idea: the laying down of a buoyant runway. It was not overly successful. The British returned to the more conventional aircraft carrier and overcame the same problems as the Americans. It was the planes from the aircraft carriers Saratoga and Lexington that would be the first to change the way sea battles would be fought in the future. The location of the battles was north of Australia in the Coral Sea. For the first time in history, the sea battle was fought entirely by aircraft. A Japanese force was rounding the north of New Guinea to capture Port Moresby. If they were successful, they would have a platform to invade Australia. The battle was fierce and losses on both sides were severe. The Yorktown's flight deck received one hit from an aircraft's bomb, but survived. The Lexington, however, took 3 hits and sunk that night. A destroyer and an oiler were also sunk. The Japanese lost a carrier, with another one damaged. Only a month after the Coral Sea, Japanese codes were broken and the information was devastating to the Americans. It was learnt that Admiral Yamamoto was planning a massive attack on the strategically valuable Midway Islands. This battle was to become known historically as the Battle of Midway. The odds for the Americans seemed overwhelming. They had no battleships. The Japanese had 9. 8 American cruisers against a force of 15 Japanese cruisers. The American carriers, the Hornet, Yorktown and Enterprise, were to face 4 Japanese carriers. However, the Americans had one advantage, and that was surprise. The Japanese were unaware of the American carriers, and when the planes started their attack, the Japanese were caught with flight decks packed with planes, fuel, and high explosive bombs. In the commotion, They couldn't get their planes in the air quickly enough. When the battle was over, all the Japanese carriers and one cruiser was on the bottom. The Americans fared better, but still lost the carrier Yorktown with more than 100 aircraft. This was the second time that aircraft had been the major factor in a sea battle, and now the pressure was on to develop planes specifically for carrier work. June 26, 1942, just after the Battle of Midway, a new plane rolled out from Grumman's factory. Some people interpreted the plane as the Grumman Wildcat's big brother, but this wasn't so. This was a totally new fighter. This plane was designed to even the score against the remarkable Japanese Mitsubishi Zero. The Zero had for some time beaten all others convincingly. It could outrun, outclimb, outmaneuver and outshoot anything in the sky over the Pacific from 1940 to 43. A Curtiss P-40 or a Wildcat may outdive the Zero and avoid it, but in every other aspect, the American pilots knew the Zero had it all over them. In one dogfight, 23 Zeros took on 50 Dutch and American P-36 and P-40 fighters. The Zeros downed more than half of them with a loss of only 3 of their own. The Hellcat was about to challenge this air superiority. Combat reports told the Grumman engineers that a few minor refinements to the Hellcat in production would improve the already unbeatable plane. A water injection system was installed to the engine to give the pilot short bursts of extra speed in an emergency. The engineering of the aircraft was also remarkable. Never before or since have such a great number of planes rolled out of a single factory. However, within 3 years of the delivery of the first Hellcat, the production line ceased. During the production run, over 12,000 aircraft were built. There were only 2 major subtypes of Hellcat. The only real visual difference between the 2 types is the Model 3's extra window behind the cockpit. This was removed in the later model as it had no value. Not making submodels, which would have required time-consuming retooling, was one of the reasons Grumman was able to have such a high output of craft from a single factory. The other factor regarding the output was the superb organisation. The factory was a model of quality mass production. During the production run of Hellcats, even the colour scheme was not tampered with. Only one change was made over the 3 years. The original 3-tone blue camouflage gave way to a dark navy blue that at times appeared so dark it looked black. The first Hellcat was delivered to the Navy on January 16, 1943. Once the plane was finished, Grumman test pilots flew the plane and noted any irregularities. A dangerous job, and interestingly, there were a number of women test pilots. This wasn't unusual, as women were used to ferry planes from all the US factories to the land bases that the planes would leave from for their combat roles. Not only did the women test fly the planes, they also operated the control tower and many other facets of the test program. The women were test flying the plane that was the key to victory in the Pacific theatre of World War II. The Hellcat was primarily designed to be used on carriers, although a few were flown from land bases. The Hellcats were deployed firstly to the larger carriers like the Essex class. With the rate of aircraft losses due to the Zero, the Hellcat was pressed into service as quickly as possible. They literally packed the decks of the carrier groups with Hellcats. On April 5, 1943, a Hellcat squadron downed the first Zero, and this was the way it would be for the remainder of the war. One month later, over New Guinea, another was down, and the score was 12 Zeros lost to 4 Hellcats. The Hellcat was described by pilots as easy to fly and very stable to shoot from. Most importantly, it performed greatly at both high and low altitudes. The Grumman philosophy when designing the Hellcat was make it strong, make it simple, and make it work. The Hellcat was in fact a reasonably simple machine, and it was definitely tough, and it did work extraordinarily well. The Hellcat got a reputation for its ruggedness, and even when shot up badly, it could bring its pilot home. During June 1944, the Hellcat broke the back of the Japanese Zero. This was the Battle of the Philippines and was described by one American pilot as the Great Marianas Turkey Shoot. By the day's end, the Japanese had lost 356 planes. The Allies had lost just 16. It was one of the highest American kill ratios in a single day. Without the Hellcat, it's argued that the dominance of the Japanese Zero could have turned the war. It was only the Hellcat's ability to fight off the Zero that the Pacific theater was secured by the Allies. The statistics of the F-6F Grumman Hellcat are impressive. Its battle ratio was 19-1. Of the 6,477 Japanese planes downed over the Pacific, well over 5,000 are credited to Hellcats. The plane's dimensions: wingspan 42 feet 10 inches, fuselage length 33 feet 7 inches. The power plant in the early model was one 2,000 horsepower Pratt & Whitney R2800 double wasp 2-row radial. Hellcats had 6 half-inch Browning machine guns with 400 rounds per gun. Some had 2 20mm cannons plus 4 half-inch machine guns and underwing attachments for 6 rockets. Their bomb payload of 2,000 pounds was carried on center pylons. The plane could reach a speed of 376 miles per hour and climb at 3,240 feet per minute. The service ceiling was 37,500 feet, and it had a range of 1,090 miles. After the war, the Grumman Company continued building combat aircraft. In December 1957, the US Navy selected the Grumman Corporation to fulfill the new long-range, low-level tactical strike aircraft requirement with the A-6 Intruder. April 19, 1960 was the day the Intruder first took to the air. It was one of 482 produced. The upgraded A6E, seen here, first flew on February 27, 1970, and introduced a multi-mode navigation attack radar system. The A6E was modified with a composite wing to extend the plane's operational fatigue life another 20 years. It was also equipped with a multiple mode radar. The high-resolution real-beam ground mapping radar also provides terrain clearance and avoidance for low-level navigation. The transmitter, receiver and camera are located beneath the nose in a sensor turret for precision attacks against tactical targets at night and in adverse weather. The A6E can deliver the Navy's entire arsenal of available air-to-ground weapons, from general-purpose bombs to ground attack missiles, including the AIM air-to-air missile. The integrated attack navigation weapon system, coupled with a two-man side-by-side crew, significantly enhances crew coordination, situation awareness and safety of flight. It was a subsonic two-seat aircraft fitted with the ability to carry up to 15,000 pound or numerous types of munitions. The A6 was a quantum leap in carrier-based power projection. Join us again on our next search through our brief but fascinating history of flight and aviation. Come with us and meet the people, the planes and the companies that have created the world's most technologically advanced machines.